This video is going to cover the ideal gas law and STP as it's approached in IB chemistry. The ideal gas law is PV equals nRT. It allows us to relate the pressure and the volume and the temperature of a gas to how many moles there are present. Now for IB, the way that they approach this consistently uses the same units. Pressure needs to be in kPa, volume liters, temperature Kelvin, and R is a gas constant. And that gas constant is 8.31. The units on it are joules per mole Kelvin. You may see other units as well. You won't need to use the units on it. This is something you're given in the data booklet. N is the moles of gas present. I'm going to write this off to the side. PV equals nRT. And R, being a constant, is always going to be the same value, 8.31. Let's take a look at how we would use this in a problem. So I could say, find the pressure exerted by 20 grams of CO2 at 37 degrees Celsius in a 2,500 milliliter container. So let's take a look at what I've given you. Well, we're looking for P. I've given you temperature. I've given you volume. I didn't give you moles, but I gave you enough information to get moles. So pressure is what we're looking for. Volume is 2,500 milliliters, but it needs to be in liters, so I need to convert that. 2.5 liters. Remember, IB would also refer to milliliters as cubic centimeters, and this is dm cubed. N, I'm going to find before I plug it in. R is 8.31, and the temperature is 37 degrees Celsius, which I need to convert to Kelvin by adding 273, giving me 310 Kelvin. Okay, so let's talk about moles now. 20 grams of CO2. 20 equals the moles times the molecular weight of CO2, which is 44. 20 divided by 44 gives me 0.455 moles. Pressure, what I'm looking for, volume 2.5, moles 0.455, R is 8.31, and the temperature is 310. I get a pressure of 469. What units? kPa. Next, we'll talk about what STP means. We're going to find the mass of CH4 in a 6.25 liter container at STP. STP means standard temperature and pressure. For our purposes, standard temperature is 0 degrees Celsius and standard pressure is 100 kPa. Some texts you'll see use 101, some use 101.3. In the data booklet, they'll give you 100 kPa to use at STP. So I'm looking for the mass of CH4, which means I need to solve for the moles. I know the pressure. I know the volume. I know R, because I always know R because it's constant. And I know the temperature to be 0 degrees Celsius or 273 Kelvin. So I know most of what I need to know for PV equals nRT, which means I can solve for moles. And once I get moles, I can then solve for grams. So PV equals NRT. 6.25 times 100 divided by 8.31 and divided by 273 gives me 0.275 moles of CH4. To solve for the mass, good old grams equals moles times molecular weight. CH4 has a mass of 12 plus 4 hydrogens, a total of 16.